Hey, welcome to part two. We left off on level 3 chargers, or also known as DC fast charge. It depends who you talk to. Just let it go. Some people get really picky about it, but um, usually kind of snooty people. Anyway, we left off on this CHAdeMO plug, which is real popular on Nissan, and actually I've seen this on the Toyota Mirai too in the trunk. So this is something Japanese like to use, DC fast charge. These are 4-pin, uh, basically communication plug up here and down here. Where one's only using at this point, the other one's for expansion, but who knows. All right, so another cool charging method, which is interesting. Yeah, that's outside the box, is just change the battery with one that's already pre-charged. So you take it off, you trickle charge this battery pack. A person rolls into the service center. Tesla had this idea where you take out their dead battery and you plug in a fully charged one. That time's quicker than actually charging the dead battery. And so you kind of lease these batteries and they kind of get swapped out as you travel along the highway. It was really popular when it came out, and then it completely went away. They had a lot of problems with it. Obviously they're liquid cooled, as we've discussed before, and trying to burp it, a quote unquote burp, right, to remove the air, and it's just too many nuances. So it kind of went away. But I actually heard recently that they're talking about bringing this back again. So who knows? What is old is new, and new is old. So in this picture, you have this whole black tray right here. That's the battery of the Tesla, where it can be dropped out from underneath the car, which is by design. But look at the weight, 1,100 pounds. 26% of the car's weight is the battery. But look how low it is too. A good center of gravity. Oh, that's why the handle's so good. Cool car. So, quick pop quiz. Can you identify these plug-in ports? What do we have on the left? CHAdeMO. That's right. Your DC fast charge CHAdeMO, and that means on the right you have your SAE J1772. Again, you have your AC ground, hot, neutral, and your proximity and pilot communication plugs right here, which we'll talk about in a little. And then here's your Tesla plug. They kind of dance their own drum or beat their own tune or whatever, beat their own drum, whatever you want to say. They got their own plug. So if you look right here, you push on this reflector on the side of the car on this Model S, and actually the Type 3 has one very similar. You open it up and here's your charging port access. But they do come with adapters, so you can adapt to other people's plugins. Their charging stations are actually, they're kind of, they communicate to an account, so you sign up with an account and they charge you. You don't actually pay at the charging station. So you don't need adapters for other cars to theirs, because you're not going to be able to get into their network anyway. Batteries work best when operated or charged within a comfortable temperature, as discussed on previous lessons, 68 to 78 degrees Fahrenheit. So before charging the vehicle, can warm up or cool down the battery using the HVAC system. So think of it this way. If you're going to basically charge the vehicle, take off and turn on the AC or the heater, you're going to diminish your range. Wouldn't it be cool if you can turn it on ahead of time while it's plugged in? Well, that's what plug-in hybrids and electric vehicles do, since their AC is basically driven off electric motor, not an ICE. They can run the AC through the chiller, or they can heat up the battery. They can heat up the cabin through resistive heating, turn on water pumps, turn on the fan. All this can happen while it's plugged in, so the battery stays charged and the cabin is climate controlled to whatever your preference is before you take off. So you can leave it off while you're driving, extending your range. Kind of a cool idea. And some cars even have little in their fob. It's connected like this leaf fob. You can actually turn on and monitor it from the fob. So pretty cool. And I'm going to link an article on how the J1772 communicates. It's pretty heavy on a lot of installing lingo, because it's meant for installers, but it's going to give you an idea of how the proximity pilot pins work, the duty cycling, and basically what it does, it talks about the proximity pin is going to be, if you plug this connector in, the car can recognize that. And also if you're hitting the button, the release button, it's going to recognize that through this proximity pin. This control pilot pin, this is what sends the communication back and forth to start charging, stop charging, and at what rate. Okay, so that's what that does. And then you have AC line 1 and 2, your hot and neutral, and then the ground. And again, that's kind of the gist of how those work. Another style of charging is inductive wireless charging. Kind of neat. A couple different pictures going on here. Nissan has this where you back in to this charging coil that's plugged into a EVSE right here. Nothing gets plugged into the car. It sends out current, an AC current in this inductive coil, much like this picture over here. It's going to send out that magnetic field around it, and you have a device put onto your Leaf, or it can come on certain cars factory is the idea, that then it would basically through induction, it would charge this coil on your car, which is connected to the battery, and then that would charge the battery. Much like your wireless chargers for your cell phones work. Okay, so it's an inductive, AC inductive charger, wireless charger. And I will attach an article about that too if you want to read on that. Here's some old school GM EV1 charging. You plug this into the hood. That's about it we're talking about on that one. Moving on. No, yeah, this is kind of the prototype of EV in America, really. It came out in the 90s and then kind of went by the wayside. A lot of speculation and theories as to why. No one really knows. Did GM want it to succeed? Don't know. It did use lead acid batteries, and that was prone to failure. So who knows what the reason was. So again, we talked about earlier, the PHEV is a modified HEV. The battery electric vehicle is a modified PHEV. So you kind of just get rid of the ICE and go even with even bigger batteries. Okay. So it just keeps getting those batteries bigger, and then the ICE goes away. And then boom, you got an electric motor, which is cool because you know how to work on electric vehicles because you know how to work on hybrids. So all that safety, the PPE, the live dead live, the deactivation, the isolation testing, phase-to-phase testing, all of that works on an electric vehicle. Pretty cool. That's why I like physics and theory. So typical BEV has an electric motor that ranges in power from 80 kilowatts and 350 kilowatts. That's huge compared to the Prius 50 kilowatt motor. Now keep in mind 1 horsepower is about 745 watts. So, but that's kind of a rough, and you can round up to 746. And if you look at that 350 kilowatt motor, this is on your Teslas, that's 746. Let's see here. You got, let's see, but oh, I got it right there, 470 horsepower. Pretty cool. That's quite a bit of power. And keep in mind, electric motors are rated at constant horsepower delivered, where ICE is rated at peak. Think about a dyno chart. If you're looking at a gasoline engine as dyno, you're going to look at it. It climbs and climbs and climbs, and it peaks and then drops off. They can rate that ICE at the peak. Electric motors are different. It has to be constant horsepower, constant power delivered. So, and they're got really high torque at right off startup, low RPMs. So, win for the electric motor. And remember I mentioned earlier, the cars have the charging module on board. Well, here's Focus EV, like the one we have in the shop. Its charging model, the BCCM, is underneath where you would see a driveline or exhaust on a gasoline vehicle. They stuffed in the charging module to the battery and all these coolant lines that go to that battery charging module and back to the battery to keep it cool. So potential for leak, yeah, something to think about. So I mentioned earlier range anxiety. So BEV owners experience what's called range anxiety, meaning how far can I travel away from home and make it back? You get kind of anxious when there's nowhere you can't just pour electrons into the battery. You get kind of out far away or can't find a charging station, and it's you get what's called bricked. Then you got to just tow it back. You can't carry electrons in a gas can. So something to think about. What affects range? Well, of course, temperature, right? But what else affects? Battery energy storage capacity, the vehicle weight. Are you hauling a lot of cargo? More than what factory recommended? Ambient temperature, as discussed. Terrain, as if it's hilly. Using accessories such as AC or heaters. All of these things can diminish your range way less than what the factory says. So if you're going off what the factory says, like 70 miles, be cautious. The car will actually kind of learn how you drive. Like if you drive on a lot of hills, it's going to guess on the range based on your load and your usage. And that can change with different drivers too. So it's all a guesstimate. It isn't like you're measuring a liquid fuel in a gas tank. It's using, remember, temperature, current in, current out. It's going to measure voltage. A lot of different things go into calculating this, how you drive, your load, etc. So not super accurate, but you get a gist. So how far can I go? Let's see, rough estimate is take the size of your battery in kilowatt hours and then multiply it by 3. And again, this is going to be a rough estimate. For example, if you have a 25 kilowatt hour battery, that's going to get you about 75 miles. Okay, again, that's rough estimate. And there's the math. So that basically concludes part 2. And we just went over briefly, talked about plug-in hybrid differences, electric vehicle. You really do know more than you think when it comes to working on them. If you know how, temp sensors work, basically negative temperature coefficient thermistors, those 2-wire sensors, how 3-wire sensors work, Hall effect sensors work, position sensors work for all those coolant control valves. You know how to work on coolant leaks. You know how to test electric motor stator. You can deactivate the car safely. You can do a lot more than you think. You can interpret PIDs. You know how to read battery data, right? Internal resistance between 25 and 35 milliohms. So state of charge, where does it range from? All of this stuff is accumulating to make you a better entry-level technician. So stick with it. Keep studying. I'm going to link a few articles on those pins, the pilot and proximity pins on the charger. If you're interested, I highly recommend learning how those work. And that's basically it. If you have any questions, email me, and I'll see you next week.